Identities is the relationship or identities that show the relationship between the six trigonometric ratios. But if put properly mathematically and from what it is, you say that standard identities is the application are the identities gotten from the application of the Pythagoras. I'm answering the first question. Application of the Pythagoras theorem. Identity gotten from the application of the Pythagoras theorem to show the relationship between the six trigonometric ratios. And these standard identities gives us what we call the Pythagorean identities. So what are they? The second question says give the three major Pythagorean identities. Number one is to remember that from Pythagoras theorem, hypotenuse square is equals to x axis square plus y axis square. So for a unit circle, we'll consider a unit circle to be a circle whose radius is equals to 1. I can say a circle that is not moving. Or anytime you're thinking about something that is constant, you say that is equals to 1. So call hypotenuse here 1. Because if you know that if this is supposed to be a unit circle, for example, if I put this x, y, this part is the radius, which we say is equals to 1. So call this 1 square equals to x square. I proved it in the first video. Why we said that? Because whenever angle is made with the horizontal, x is equals to cos theta, y is equals to sine theta. If I know this, call this cos theta square, or you say cos square theta plus sine square theta. So this is the first Pythagorean identity, which is 1 equals to cos square theta plus sine square theta. Now from this first Pythagorean identity, we can get different things. Anytime I'm solving anything and I see cos square theta plus sine square theta, it's expected of me to just say that thing is 1. For example, if I'm solving, like, let's say I have cos square theta plus sine square theta all over sine A plus sine B, it's expected of me to just say that this is equals to 1 over sine A plus sine B. That is why I say you need to know all these identities, all these equivalencies, so that you're able to know when to be solving. That's why sometimes you are solving arithmetically when it has to do with trigonometry and it looks as if you're not getting it right. That's because you don't know all the identities. It's important. Once you know all the identities, and you always pay attention to your triangles, what the hypotenuse are, because there are things that you'll be solving that requires you replacing whatever you have with the Pythagorean identities or the Pythagoras theorem, or the equivalence of the Pythagoras theorem, like I did when I was deriving all those double angle identities. So if I know this, making cos subject of the formula here, I can say cos square theta will be equals to 1 minus sine square theta. So anyway, I'm solving something and I see 1 minus sine square theta, I just go and replace it with cos square theta. I'm making sine square theta subject of the formula. This is equals to 1 minus cos square theta. Cos square theta is the same thing as saying cos theta square. Anyway, I'm solving and I see 1 minus cos square theta, I replace it with sine square theta. But if I'm solving and I have sine square theta, if maybe I've not started solving, I'm giving something of sine squared theta, I can just replace sine squared theta with 1 minus cos squared theta. It depends. Whenever you want to prove something, you need to put these two hand to hand because they are equal. Now, to derive the second Pythagorean identity, I come to this thing that I have, which I derived from the Pythagoras theorem. I say, let me say I'm dividing by cos. So I divide through cos squared theta. Divide everything here by cos square theta is the same thing as saying cos square theta all over cos square theta. Notice 1 over cos. From when I taught you trigonometry the first class, I told you that 1 over cos is the same thing as secant. So since this cos is having square, it's the same thing as saying sec square theta is equals to cos square theta by cos square theta. Anything divided by itself is 1 plus sine divided by cos is tan, and since this one is square, it will be tan square theta. This is the second trigonometric identity, and from this second trigonometric identity, if I make 1 subject of the formula, I will have 1 equals to sec square theta minus tan square theta. Anytime I'm solving something and I see sec square theta minus tan square theta, I can replace it with 1. If I make tan subject of the formula, tan square theta subject of the formula, I will have that this is the same thing as saying sec square theta minus 1. So very important to note. Now the third identity, or the third Pythagorean identity, or you say standard identity, is as I have that my first identity derived from Pythagoras theorem, I have 1 equals to cos square theta plus sine square theta. If I choose to divide by sine square theta, divide by sine square theta is the same as saying sine all over sine square theta all over sine square theta. 1 over sine is the same as cosecant, if you remember. So since this one is sine square, it's the same as saying cosec square theta is equals to, anytime you have sine over cos is tan, and if you have cos over sine, it's like reversing tan, and 1 over tan is cotangent. So this is cotangent, but since they are all in square, it's going to be cotangent or cot square theta. Then sine square divided by itself is 1 plus 1. So this is the third trigonometric identity. So number 3, number 2, number 1. So from this third trigonometric identity, I can now have when I make 1 subject of the formula, I will have that 1 is equals to cosec square theta minus cotangent square theta. So cosec square theta minus cotangent square theta is equals to 1. And if I make cotangent square subject of the formula, I'll have that cosec square theta will be minusing cotangent square theta. So please bear with me on this piece. So this is theta. So if I know this, there you have it, the 3 major standard identity, or 3 major Pythagorean identities. So you derive it. If you feel the one I did or the one I'm doing is not okay, you try your own so that you get a clearer view. I'm in between so much works, and still I'm finding time to do this, so I'm not taking my time to edit and all that, but I just want to pass the understanding for you that is preparing for exam. All the best. Subscribe to my channel.